Hey guys, my name is Jason with Mount Baker Mining and Metals, and today we're going to be doing a video shredding up some old PC towers, grinding them up on our PCB system, and then trying to smelt down the metals to get an ingot that we can analyze and see what kind of metals are in PC towers. And the experiment actually doesn't really go the way I'd hoped, so be sure to watch all the way till the end of the video and let me know what you think I should do different on our next experiment. So here is our 34 by 24 inch hammer mill grinding up the PC towers, and this is a shot from one of our older videos, and to see the full clip you can click in the card on the upper right hand screen. But this is shredding the whole PC towers, and then the material goes under this crossbelt magnet, which is sucking up all the steel fraction and pulling it into a separate bin, and then the conveyor belt takes everything else up and discharges into a bin for further separation. Now we're going to take all of our ground up PC towers with all the steel removed, and most of it's little pieces of board, some copper wire, some pieces of plastic, and we're going to run it through our PCB system, which is a 16 by 12 hammer mill, grind all that stuff up down onto one of our 4x8 shaker tables, and recirculate the water. The metals are going to come across the table this way down into the number 1 and number 2. The middlings are going to come down into here into a middlings fraction, and then the number 4 here is going to be waste. The material is being fed into our 16 by 12 hammer mill, and we run water down the hammer mill to keep the dust down, and it also helps make a slurry for feed directly onto our 4 foot by 8 foot shaker table. In this shot, you can see the light plastic, and everything that floats is flowing directly down towards the number 4 tailings trough. The denser material, aluminum, and some of the lighter metals are kind of angling down at a 30-degree angle along the ramp right at the end of the grooves. And then all the denser metal, the copper, lead, and precious metals are coming up under the water bar here and are flowing down into the number 1 and number 2 concentrates. The water is pumped from the settling basin up this hose into the back of our 16 by 12 hammer mill, which lubricates the system and makes a nice slurry that goes down onto the shaker table. The water is then discharged into the pond and recirculated again. Also, while we're here, I wanted to talk a little bit about recovery. We get questions asked a lot about, how much gold do you recover, what percentage do you recover. We've done a lot of experiments with PC boards, just the straight motherboards, and we can recover about 95% of the copper, about 90% of the silver, and about 85% of the gold. And motherboards, kind of your average run-of-the-mill motherboards, are going to have somewhere around 3 ounces of gold per ton, 15 to 30 ounces of silver per ton, and they're going to have about 25 to 30% copper by weight, along with lead and some tin and some other things. So, but that's where most of the value is. And there's a couple different strategies. Some of our customers want to grind the boards really, really fine, get all the metals out, and get a really, really high recovery rate. And other customers take a different strategy where they actually leave enough metals in the number 4 waste to where they can still sell that as a product to a refiner or a smelter, and then you don't have any waste streams. All your material gets sold, and then you don't have a waste problem. So that's kind of the two different sides of our customers' take on when they're processing this stuff. Do they try and get as high a recovery as they can and then have a waste product they have to get rid of, or do they actually lose some gold, copper, and silver and other precious metals to the tailings, and then they can actually sell that off to a refiner, maybe just break even on it, but at least it's a waste stream that you don't have to deal with at that point. Here's the inside of our small 16 by 12 hammer mill, and this is what we're using to grind up the boards for the shaker table. And you can see here's our hammers, swinging hammers. There's 2 rows in this mill, so there's 10 hammers total. So here's the screen. It's about a 1/4 inch punch plate hole, very similar to like a granulator screen. And the hammers just go around real fast, and anything that goes in there has got to be crushed down to 1/4 inch or smaller to go through those holes and then down onto the shaker table. So here's the metal that we ended up with from those PC towers. This is the number 1 here. I've got it all spread out on a table to dry. And this is the number 2. But you can see here kind of the characteristic. Again, this is the number 1. Quite a bit of copper wire in there. Lots of little aluminum BBs that get rolled up into balls. Here's the number 2. There's a little bit more plastic in the number 2, but a lot more fine copper wire than gets in the number 1. All right, so now we have our number 1 here and our number 2. It's been all dried out. I'm going to get a weight on it before we put it in the crucible and melt them down. But if you've gotten this far in the video, you're probably asking yourself, what's the point? Why are we doing this? And the reason why I'm doing this particular experiment is I want to get all the metals out of the PC towers, but then it's really hard to get a representative sample of all the metals because there's big pieces, and if you take a scoop and you miss pins, then there's not as much gold as you think there is. So we're just going to melt it all down all together and pour it into bars so it's all homogeneous and uniform, and then we can get it zapped with our XRF gun and get an actual value or an actual percentage of the metals in the stuff. And also, I know that there's some environmental concerns, there's some safety concerns doing this. This stuff's pretty nasty. I don't recommend this as a way to process your PC boards and some of your heavier metals. This is really just a demo and experiment just to find out how much gold and copper and other metals are in this stuff. So again, I'm not a proponent of processing PCs in this way. It's just a way for us to get more information about the system. So with that, we'll get this stuff thrown in the crucible, and we'll melt it down and pour some bars. Here's our number 2 on the left and number 1 on the right. And a couple things before I put them in the crucible. I've kind of been agonizing over whether I should use flux or not on this. Throw some borax in there. and try to help get all those oxides off. And I've decided not to really do that. I'm going to try and just melt them down. There's going to be a lot of dross and crap on top, but I'm going to melt them down so I can scrape all that dross off and get a metal puddle at the bottom that we can pour. And if that doesn't work, then we can always just take all that crap and put a bunch of flux in it and flux it a second time. The other thing I'm not going to do is I'm not going to pull any steel out of here. There is some steel and some iron in here still, probably some stainless as well. And I'm going to see if I can let that all sink to the bottom and let it come out. I'll just scrape it out of the bottom of the crucible rather than adding another step of taking out the ferrous. I'm hoping that we won't be able to get, obviously we won't be able to get hot enough to melt it. And so it should sink down to the bottom and just come out when we scrape out the crucible. So that's the plan there. We'll get this loaded up in the crucible. I'm going to put the number 2 on the bottom and the number 1 on top and melt them down together in our furnace, which is right over here. It's our KO furnace. So we'll get this thing fired up here and we'll show you how it works. We just poured our number 1 and number 2 into the crucible here. This is a number 80 crucible. There was 12 pounds of number 2 and 25 pounds of number 1. So that comes out to be right around 1.5 pounds of metal per tower, I believe. I figured we got about 25 towers that we crunched up. I actually didn't get a real good count on those because I wasn't planning on melting down the stuff that came out of them. But anyway, there's our crucible. We got our KO wool, 2-inch KO wool wrap there. We put a lid on there. We run it off 2 propane bottles. There's one there, one outside, and then we have our little shop vac for a blower, and it goes down and splits the propane and the shop vac. Both feed into this injector here, and then it feeds the furnace. Almost up to temperature. I don't know if you can see in there, but I had to add a bunch of borax because the stuff was all small. I think it was oxidized, and I've been stirring it a little bit, and it feels kind of sticky on the bottom. So I don't really know what we're going to get, but we'll pour it over here into our cone mold. And hopefully all the metals will go to the bottom down there, and the slag and the borax will sit on top. And we'll see what we get out of these circuit boards. Shoulder 1, 2, 3. And then the control right above your head there. Down a little bit. There we go. Ready? Yep. I'm going to go slow at first. Come up a little bit. There we go. there's a bunch of crap in there. Come on, metal! Whoa. That was good. Alright. All left in there. Well, there's what we got. There's our borax, and some metal came out of there, and then there's just this big glob of junk here that I guess didn't melt, or the melting temperature is too high or something. So anyway, that's what we got. We'll let her cool down and see what happens. So here's our cone mold. It's cooled down now, and we'll get that knocked out of there. And then after our pour, there was actually a whole bunch of crap in the bottom of the crucible that we scraped out. And you can see it here, so I'm going to bust that open and see what it is. But that's a little bit concerning because it didn't melt. It was kind of sticky. I think I mentioned earlier when I was stirring the crucible. I don't know what that is. It might be like ceramic pieces that didn't melt, or you know, some higher temperature metals that didn't melt. But we'll see what happens here when we knock the thing out of the cone mold and see how much metal we got. Let me get a hammer, I'll knock this out of here. So I got it knocked out of there. There's our metal cone. And I'll get it cleaned up a little bit and we can take a look, but you can see all the slag underneath there, and there's our metal part. So I've taken it and I've kind of polished it up a little bit, and it's actually kind of brassy colored. It's like a real light, kind of shiny yellow, which is surprising. I thought it would be silver and more like aluminum. It's pretty heavy. I'll get it weighed here, but I'm going to take it over and get it analyzed with the XRF gun, and we'll see exactly what kind of metals we got in here. Here's that stuff we scraped out of the crucible at the end of the pour after the metal was poured off, and there's all sorts of little metal chunks in there and junk, and I don't know. There's a lot of metal in there. It's actually really pretty heavy. But I don't know why it didn't all collect down in the bottom. It's like it almost didn't get hot enough to melt it. So I'm not really sure. We'll see if we can get this zapped with the XRF gun too, and see what this stuff is, because this kind of baffles me. It didn't turn out like I wanted it to turn out. So the mystery continues here. Okay, so we just got it zapped with the XRF gun, so I'll show you the results right now. And then here's a chunk of that slag I also took to the XRF gun, and I'll show you those results now. All right, guys, so what happened? I'm not really sure. We ended up with a cone of metal at the bottom that had primarily the copper and some lead and tin, as well as a little bit of zinc. And then the aluminum and the iron with a little bit of copper ended up in that slaggy junk that floated on top. So my only thought is the aluminum and the iron are more reactive metals. And a lot of those small pieces of wire and things like that were oxidized, and so the copper oxide interacted with the aluminum and iron metal, and the copper and lead were reduced, and the aluminum and the iron were oxidized and ended up going into the slag. But I'd really appreciate it if you guys had some thoughts on this. What happened? How can I do it differently in the future to get better results? So that's what happened. That's what happens when you melt down the non-ferrous metals from about 25 PC towers. I hope you guys enjoyed the video. If you have any questions or comments, let us know in the description below. Otherwise, we'll see you on the next one. Thanks for watching.